In today's video, we are going to talk about the transportation problem using Modi method. Modi method is a modified method for the solution of the transportation problems. So let's get started. The first step to solve the transportation problem by using Modi method is to solve the transportation problem using basic solution. In question you have given a table from which you have to calculate the transportation problem by using Modi method. But before going to the Modi method, you have to calculate the basic solution by using NWCM, means northwest corner method, lowest cost entry method, VAM, Vogel's approximation method. So these are the basic methods to get the basic solution of a transportation problem. After getting the basic solution, the second step is to check the optimality of a basic solution by calculating the value of unoccupied cells using R1 and K1. So this is a practical aspect. I will talk in detail about it in the question itself. The third step is, after checking the optimality, if the solution is not optimized, that is the answer which we have got from the basic solution is not optimal, is not decreased our cost, or our cost is still maximum as compared to the others of our transportation, then if the solution is not optimized in the basic solution, then we have to use an unoccupied cell to calculate the optimality, and this step will going to repeat till we get optimized result. Talking about these basic methods, I have told these methods already in my previous video, so please refer my previous video if you are not able to got these three methods. I will give the link of these three methods in my description. So this is the question which we are solving today. Supply and demand is given. The first step is to check the demand and supply, whether the both supply and demand are equal or not. 56, 82, 77 is equal to 215. 72 plus 102 plus 41 is equal to 215. So the first step is checked and it is correct. Demand and supply is both are equal. After checking the demand and supply, we have given, that is the demand and supply are already matched, that is they have given a question which is include the Vogel's approximation method. The basic solution which I used is VAM, Vogel's approximation method. By using the VAM, I have assigned the supply to the demand and matched this demand with supply. 56 supply, 72 demand, 102, 82, 77, 41. So after using the basic method to get the solution, we have got this table. Remember the first point, first step, solve the transportation problem using basic solution method. I prefer this method, VAM, Vogel approximation method. So I have used this method to get the basic solution in the practical question. So by using the VAM, I have got this result. After that, after getting the basic solution, we have to check the optimality of this solution, whether this result is optimized, whether we got the minimum transportation cost. So the procedure to check is find out the unoccupied cells to whom we can assign the supply to cover the demand, and to check whether that unoccupied cell is able to give the minimum cost. So here are 1 2 3 4 1 2 3 4, total 4 are those cells which are unoccupied. First of all, we have to check whether the condition of m plus n minus 1 is satisfied. If it is satisfied, then there is no need to give degeneracy. M means number of row and n means number of columns. So row are 1 2 3, 3 plus 1 2 3 minus 1, 6 minus 1 is equal to 5. So if we have to proceed without adding the degeneracy, there must be a minimum 5 number of occupied cells. 1 2 3 4 5. So the condition is satisfied, we have to proceed, we can proceed. So after checking or after fulfilling the condition, we have to find out the unoccupied cells. The unoccupied cells are, first is WB, WC, XC, YA. These are the unoccupied cells. Let's check the second step which we have considered. The second step is check the optimality of the basic solution by calculating the values of unoccupied cells using R1 and K1. So these values are to be added in the table R1 and K1. Here we are going to write R1, R2 and R3, K1, K2 and K3. The value of all these are unknown till now. First of all, we have to give a value 0 to any of these three, R1, R2, R3. You can give value 0 to any variable, whether it is R1, R2 or R3, but I prefer to give 0 to R1. After giving value 0 to R1, we have to calculate the all values. Now we have to consider only occupied cells for calculating the value of R1, R2, R3, K1, K2 and K3. How to calculate? R1 plus only occupied cells, K1 is equal to 4. R1 K1 is equal to 4. The value of R1 is 0 and the value of K1 is unknown. So K1 is equal to 4. In the same way, we have to calculate the all values. In this row, there is no one which is occupied, so consider this 4. Means R2 plus K1 is equal to 16. R2 is unknown and K1 is 4 as calculated above. So R2 is equal to 12. 12. In the same way we have to calculate K2, R2 plus K2 is equal to 24. R2 is 12 plus K2 is equal to 24. K2 is equal to 24 minus 12. K2 is equal to 12. Now with the help of K2 we can find R3. R3 plus K2 is equal to 16. R3 is unknown. K2 as we have calculated 12 is equal to 16. So R3 is equal to 4. By using R3 we can get the value of K3. R3 plus K3 is equal to 24. R3 is 4 plus K3 is equal to 24. K3 is equal to 20. So after getting the values of R1, R2, R3, K1, K2, K3, we have to calculate the values for the unoccupied cells. So how to calculate? Let's see. WB, write this value 8 minus 0 corresponding row minus 12 corresponding column, minus 0 minus 12. In the same way WB 8 minus 0 minus 20, XC 16 minus 12 minus 20. In the same way YA 8 minus 4 minus 4. So calculate the values of all. So we got minus 4, minus 12, minus 16, and the last is 0. These are the unoccupied cells, and these shows that there is a reason to believe that the answer which we have got from the basic solution is not optimized. That is, there is something that to be corrected by using the unoccupied cells. This negative signs shows that there is also a decrease in the transportation cost if we use these values or these cost XC. So out of the all we have to select the highest negative. 16 minus 16 is the highest negative, XC. We have to make the loop in this 16. We can only make the loop between the occupied cells. This is the unoccupied cells. This can make the loop in this way: 16 24 16 24. We have to make this cell occupied to calculate whether by giving this cell a occupied cell and the other to be a non-occupied cell, there is a change or there is a decrease in the total transportation cost. If there is, then we have to make this cell a occupied cell and the other which increases our cost to be a unoccupied cell. So let's do it. So now the highest is selected. We have to make changes in this 16, 24, 16, 24. The occupied 66. This is unoccupied 41 and 36. I have told in the previous video how to make loops. This, and this. The starting point at which we have started our loop is positive, negative, positive and negative, plus minus plus minus. In this we have selected the highest negative. In this we have to select the lowest negative. These are positive, these twos are negative. The lowest negative is 41, so we have to consider this 41 and add 41 to this to make this unoccupied cell a occupied cell. 41 and to minus from this 41, this will become 0. So now this is unoccupied cell, this is occupied cell. In the same way we have to add 41 in this and minus 41 from this. So this will become, after adding 77, this will become 25. So now we have to make these changes in the table too. Now in this 66, 25 is to be right. In this 77 is to be written. This cell became unoccupied cell, 0. This cell became occupied, so give it 41. The whole rest will become equal, means there is no change in the rest of the cells. The only change is to be considered in these 4 cells. Let's do it. So here 25, 77, unoccupied 41. The supply and demand will remain same. 56 plus 16, 72. 25 plus 77, 102. 16 plus 25 plus 41, 82. 77, 77. Unoccupied cell. After change we have got a new solution. Now again we have to check the optimality, whether this new solution or new table is optimized or not. In the same way we have to calculate again R1, R2, R3, K1, K2, K3. Let's calculate the value. R1 plus K1, give it a sign 0. The value will be 4. R2 plus K1, R2 plus K1 is equal to 16. The value of R2 is unknown, K1 is 4, so R2 will be 12. Now calculate the value of K2. R2 plus K2 is equal to 24. The value of K2 is unknown, so K2 is equal to 12. After that calculate the value of R3. R3 plus K2, R3 plus K2 is equal to 16. The value of K2 is 12. So R3 is equal to 4. Now here this is a change. Previously this is the occupied cell, we used this to calculate the value of R3, but now we have to use this to calculate the value of K3. All these are same, but there is a change in this value because there is a change in occupied and unoccupied cell. So calculate the value of K3. R2 plus K3 is equal to 16. Value of R2 is 12. So K3 will be 4. Previously it is 20, but now it is 4. After calculating the new values of R1, R2, R3, K1, K2, K3, we have to calculate the optimality. In the same way, find the unoccupied cells WB, WC, occupied, YA, YC. The value of WB is 8. 8 minus 0 minus 12. WC 8 minus 0 minus 4. YA 8 minus 4 minus 4. YC 24 minus 4 minus 4. Now again calculate the value. 8 minus 12 minus 4. 8 minus 4 4. 8 minus 4 minus 4 0. 24 minus 4 20. 20 minus 4 16. Now again there is a one value which is showing a negative sign, so we have to select this value, that is WB. WB. Now select the cell and make the loops. This cell makes the loops in this way: 8, 24, 16, 4. So we have to make change in this 4 cells. Let's do it. So select this. Value is 8, 24, 16 and 4, and they occupied 56, 16 unoccupied and 25. The loops are made in this way. So plus minus plus minus. In this we have selected the highest negative. In this we have to select lowest negative. The lowest negative is, these twos are positive, so the lowest is minus 25 or minus 56. It is minus 25. So we have to add 25 in this cell to make it occupied, minus 24 from this cell to make it unoccupied, add in 25 this cell and minus in this cell to calculate or to get the new values of new cell. So we got 41, 25 minus 56, 31. After calculating the new values, you have to add these values in these respective cells. In 56 we have to write 31, where it is 16 we have to write 41, where it is 25 we have to make it unoccupied cell, and the unoccupied cell we have to make it 25. So this is our new solution: 31, 41, unoccupied and this is now occupied. Again we have to calculate the R1, R2, R3, K1, K2, K3. Remember the third step, or recall the third step, in which we have read that if the solution is not optimized in the basic solution, then we have to use an unoccupied cell to calculate the optimity, and this step will going to repeat till we get optimized solution or optimized result. This is our third step. If the solution is not optimized in the basic solution, then we have to use an unoccupied cell to calculate the optimality, and then this step will going to repeat till we get optimized solution or result. So if there is any negative value in the unoccupied cell, we have to choose this and make the changes in this to calculate the optimized result. Till now we have make the first, from where we have to got a basic solution. After that we make a use of Modi method and calculate the optimality of first table. In first table we have got the negative value, which is minus 16. We have selected that and make the changes in this cell. Afterward we have got the next negative value, that is minus 4. Selected that cell and make the changes in this cell, and now after changes we got a new table, and again we have to find the optimality of this table. If this table is again not optimized, we have to go further till we get the optimized result. We have to go further. So calculate the values of R1, R2, R3, K1, K2, K3. Give it a 0. Now calculate in the same way. R1 plus K1 is equal to 4. Here the value is 0 and K1 is to be calculated. So K1 is 4. Now again it will be a 8. From the help of this we have to calculate R3. From this R2. Calculate the R2. R2 plus K1 is equal to 16. R2 is unknown and K1 is 4. So the value is R2 12. R3 plus K2 is equal to 16. So the value of R3 is 8. With the help of R2 we have to calculate K3. R2 plus K3 is equal to R2 plus K3 is equal to 16. R2 is 12, K3. So the value of K3 is 4. After calculating the value of R1, R2, R3, K1, K2, K3, we have to check the optimality of unoccupied cells. So find out the unoccupied cells. It is WC, XB, YA, YC. The value of WC 8, minus 0, minus 4. XB 24, minus 12, minus 8. YA 8, minus 8, minus 4. YC 24, minus 8, minus 4. So calculate the value. 8 minus 4, 4. 24 minus 12, 12. 12 minus 8, 4. 8 minus 8, 0. 0 minus 4 is minus 4. 24 minus 8, 16. 16 minus 4, 12. So again we got a negative value. We have to select this value YA, make the loops and calculate the new value for this unoccupied cell. So let's do that. So the loop for YA is 8, 4, 8, 16. In this way we are going to make our loop for this. So we have to select these cells to make the changes. Let's do that. 8, 4, 8, 16, and the occupied is 31. This is unoccupied. This is 25, and this is 77. So the loop is start from this. So give it a plus sign, plus, minus, plus, and minus. In this we have selected the highest negative. In this we have to select the lowest negative. These both are in positive, so these two are negative from 36 and 77. Which is lowest negative? That is 31. So we have to select this and make the changes in this. Add 31 in this to make it an occupied cell, minus from this to make it an unoccupied cell. In the same way, add 31 in 25, make it 56, and minus 31 from 77, make it 46. So take these changes into the table. In 31 we have to write 0 to make it an unoccupied cell. In 8 we have to make it 31 to make it occupied cell. In 77 we have to make it 46. In 25 we have to make it 56. So this is the new table we have got after making the changes in the table. So now we have to calculate R1, R2, R3, K1, K2, K3 in the same way which we have done earlier. Give R1 value 0. So R1 plus K2. Now we don't take K1 because this is an unoccupied cell. We always calculate values R1, R2, R3, K1, K2, K3 with the help of occupied cells only. So R1 plus K2 is equal to 8. So the value of K2 is 8. After this, with the help of K2 we are able to find R3. So R3 plus K2 is 16. R3 is unknown and K2 is 16. The value of R3 is 8. With the help of R3 we are able to find the K1. So R3 plus K1 is equal to R3 plus K1 is equal to 8. R3 is 8, K1 is equal to 0. Now with the help of K1 we can calculate R2. So R2 plus K1 is equal to 16. R2 plus 0 is equal to 16. So R2 is equal to 16. With the help of R2 we are able to find K3. So R2 plus K3 is equal to 16. R2 is 16. K3 is equal to 0. So after calculating we have to find that the new table which we have got is optimized or not. Calculating in the same way we have to find out the unoccupied cells. WC, XB, WA, YC. So for WC value is 8 minus 0 minus 0. XB 24 minus 16 minus 8. For WA 4 minus 0 minus 0. For YC 24 minus 8 and minus 0. Now calculate the values. 8, 24 minus 16 minus 8 is equal to 0. 4 minus 0 minus 0 is equal to 4. 24 minus 8 minus 0 is equal to 16. So in this we got all the positive signs. There is a no negative sign which we have to select and make the changes. So this is called as optimized solution. Now these cells which are containing their demand and supplies are the best possible outcome, and this result is minimized cost result. This is called as optimized solution, which we have got after making 2 or 3 tables, changing again and again. So after that we have to calculate the total cost of a transportation, which is minimized cost of transportation. So calculate the total cost for W 8 into 56, for X 16 into 41, 16 into 41, for Y 8 is equal to 31, 16 into 46 is equal to, calculate करनी है total cost. So 8 into 56, 16 into 41, 16 into 41, 8 into 31, 16 into 46. So after calculation the answer 2744 is transportation cost in rupees. I hope you like this video. If it is understandable and help for your difficult questions, then please comment, subscribe, like my channel for your future and your future learnings. Till then, bye bye.